Well, hello. How is everyone this morning? All right, well, let's take the opportunity to identify relations that are functions. Hopefully, this is just a review for you. Should be. You're in a pre-calculus class. Um, we know that not every relation is a function. One way we can determine whether a relation is a function is, do we have a distinct value of y for every x? Another way, and then the same x can only equal, same x value can only equal 1y. Now, another way that if we see it on the graph, if we see a relation graphically, if we can apply and if it passes the vertical line test, then that relation is in fact a function. And the vertical line test is if we were to draw infinite number of vertical lines through the graph, it would only cross the graph at one specific point. It would not pass through it more than once. All right, so let's take a look at what we have here. We're going to identify whether relations are in fact functions. So let's see. It says determine whether each relation represents y as a function of x. First one, the input value also being the independent value, independent variable, maybe I want to say independent variable, or the domain, is the area code, and the output value, y, the dependent variable, is the phone number in that area code. So let's think about that. Well, we're in the 910 area code. Well, if that's the value of x, then that value of x, 910, is going to be equal to, I don't know how many, 10 to the 7th power, I guess, possible, because there's 7 phone numbers and each one can have 10 digits. Values of y. So there's multiple values of y, output value, dependent variable, tied to that independent variable of that area code. And so therefore, this is not a function. Got more than one y value relating to a specific value of x. Now here we have a table of x and y coordinates, -6. When x is -6, y is -7. When x is 2, y is 3. When x is 5, y is 8. But when x is 5, y is also 9. And right there, I see that I've got the same value of x, 5, equaling two values of y, 8 and 9. And so therefore, this is not a function. All right, well, shall we look at two more? You probably don't want to, but I do, and I don't really care whether you want to or not. All right, so here we have an equation. 3y plus 6x equals 18, and that's almost written in standard form, which would tell us it's a linear equation. In fact, I'm going to rewrite it in standard form. That'd be 6x plus 3y equals 18. But I also, and probably more specifically, since standard form to me is just an exercise in algebra and following a bunch of rules, I probably really would write that in slope-intercept form, y equals mx plus b. And if I can put it in that form, then it is a linear function. And if I graph it, it's going to be a line with a slope and a y-intercept. So let's see, how would I do that? I said first maybe going back to this equation right here. Let's subtract 6x from both sides. So we got 3y equals -6x plus 18. And then we're going to divide everything by 3, to isolate the y. And so now we got -2x plus 6. And I now have this in slope-intercept form, and therefore this is And if I wanted to graph it, I could go on my graphing calculator. It's going to be a line with a negative slope. It's going to be coming down and to the right with a y-intercept at 6, got a slope of -2. And so this is a function. And then finally, we've got a graph. Now, this would appear to me to be a cubic function. I see 2 terms in it. Would tell me that that's a cubic function, something of x to x cubed. And if I were to draw vertical lines through it, and even though they could get really close, I'm really only going to cross this graph at one point. And so it would pass the vertical line test, and so it also is a function. So every relation is not a function. Every function is a relation. For any value of x, there can only be one y. We cannot have multiple values of y for a given value of x.